Think about the last time you felt something was wrong before you could explain why. A tension in the air, a change in how the room smelled, a silence that felt heavier than usual. You couldn't name it, but something inside you shifted. Something old, something that didn't need language to work. Now go back. Not decades, not centuries. Go back 66 million years. A world covered in ferns and shallow seas and creatures that had ruled every continent for over 150 million years. Creatures with no smartphones, no scientists, no concept of extinction, just bodies, instincts, and a sky that was about to change forever. The question most people never think to ask is this: in those final hours, those final days, did they know? The obvious question is whether dinosaurs were intelligent enough to understand death. But that's not the right question. Intelligence isn't the threshold here. A chicken runs from a predator without understanding mortality. A fish changes course when the water temperature drops without knowing why. The real question isn't whether dinosaurs could think about dying. The better question is, did their bodies, their nervous systems, their behavior, did any of it tell them that something was ending? That question leads somewhere much stranger than most people expect. In 2019, paleontologist Robert De Palma and his team excavated a site in North Dakota called Tanis. What they found was extraordinary. A layer of rock, frozen in time, not from millions of years of slow accumulation, but from a single day, the day the asteroid hit. Inside that layer, fish with impact spherules lodged in their gills, spherules that could only have arrived in the first hours after the impact, meaning these fish were still breathing when the first debris rained down from the atmosphere. They died while it was happening. But here's what the site also revealed. In the hours before Tanis was buried, something changed in the behavior of the animals there. The sediment record shows evidence of unusual movement, sudden, disorganized, different from the patterns of normal feeding or migration. The seismic waves from the impact, which traveled faster than the debris, had arrived first. The animals felt the ground move. They felt the change in air pressure. They felt something that their nervous systems had no name for, but responded to anyway. They didn't know an asteroid had hit, but their bodies knew something had. Start with what we know about animal nervous systems and fear. Modern birds are the direct descendants of theropod dinosaurs. They share the same basic brain architecture, the amygdala-equivalent structures that process threat, the stress hormones that flood the body under danger, the freeze or flee responses that are older than the dinosaurs themselves. When a crow senses a predator before it appears, detecting a shadow, a sound, a vibration, it doesn't decide to be afraid. The fear happens first. The behavior follows. That same system was operating in the Cretaceous. Now, think about what the hours after impact would have felt like at ground level. The temperature dropped. Then, in some regions, it spiked. The sky changed color. Plant-eating dinosaurs that relied on smell and light cycles to navigate their world were receiving signals their bodies had never processed before. Not a predator, not a drought. Something outside every category evolution had prepared them for. There's a concept in behavioral biology called a supernormal stimulus, a signal so far outside the normal range that an animal's response system doesn't know what to do with it. A gull will try to incubate a volleyball painted with spots because it mimics an egg so completely that the instinct fires regardless. The Cretaceous extinction event may have been the opposite, a stimulus so abnormal, so far outside every evolved response that behavior simply broke down. Herds that would normally flee dispersed into incoherence. Predators that would normally hunt stood still. Animals that communicated through vibration stopped receiving the signals they relied on, not because they understood what was happening, because their nervous systems were receiving inputs they had no response for. But here's what's really interesting. Not all of them stopped. Some ran. Some, the evidence suggests, continued eating, found in death, with food still in their stomachs. Some sought cover. The responses varied, not because some dinosaurs were smarter than others, but because each animal's nervous system was doing exactly what it was built to do: respond to the specific signals it was receiving in that specific moment. Some signals said run, some said freeze, some said nothing yet. That variation is the most human thing about it. But here's the thing. We've been asking this question the wrong way. We assume that knowing you're going to die requires consciousness, requires language, requires the ability to imagine a future that doesn't include you. But the body has its own kind of knowledge. The stress hormone released before you wake from a nightmare, the way your chest tightens before the news you haven't heard yet, the part of you that flinches before the impact arrives. That knowledge doesn't need words. It's older than words. The dinosaurs at Tanis didn't have a concept of extinction, but their nervous systems were receiving signals that 300 million years of evolution had shaped to mean one thing: something is ending. Their bodies knew, in whatever way a body can know, before the mind catches up, they knew. There's a version of that day we'll never fully reconstruct. The exact colors of the sky, the sounds the animals made, whether any of them, in those last hours, moved toward each other instead of away. What we do have are the bones, the last positions, the frozen moments that tell us, in sediment and chemistry, what those animals were doing when the world ended around them. They weren't thinking about extinction. They were just living the way every animal lives, right up until the moment they couldn't. And maybe that's not so different from the rest of us.